12,000 feet up, sealed behind granite walls that took millions of years to carve, there's a lake with no rivers flowing into it, no streams connecting it to anything. It froze solid every winter for the last 10,000 years. And yet, when biologists dropped a net into the water, it came back full of trout. Thousands of them. So how did fish get to a place fish should never have been able to reach? For over a century, the leading theory was birds. Ducks and herons wade through lakes packed with fish eggs, and scientists figured a few eggs must stick to their feathers or their legs, hitch a ride, and drop off in a new lake miles away. It's a tidy explanation. It shows up in nature documentaries. It's been repeated so many times that most people just accept it as fact. There's just one problem. Nobody has ever actually proven it happens. Researchers have caught wild waterfowl, checked their feathers under a microscope, and gone looking for viable fish eggs clinging to feet and plumage. Study after study comes back empty. Fish eggs are coated in a sticky membrane, sure, but that membrane needs constant moisture to keep the embryo alive. A bird's leg, exposed to open air for even 20 minutes of flight, dries the egg out and kills it long before it reaches the next lake. So if it isn't birds, what about the weather? Waterspouts, the tornado's cousin that forms over open water, have been blamed for decades. The idea is that a spinning column of wind can suck up an entire section of a lake, fish included, and carry them for miles before dumping them somewhere new. People have reported it raining fish in places like Texas and India, so the mechanism seems to check out. Except when scientists actually studied waterspouts, they found something strange. The debris those storms pick up is almost always small and light. Insects, frogs, tiny minnows barely an inch long. A fully grown trout weighs several times more than anything a waterspout has ever been recorded lifting. And even in the rare cases where fish rain does happen, meteorologists have tracked the source, and it's never mountain lakes. It's shallow ponds and flooded fields close to the ground, nowhere near 12,000 feet of elevation. So the two most popular explanations for how fish reach isolated alpine lakes don't actually hold up, which means something else is going on. And once researchers started digging through old records instead of looking at the sky, they found the real answer was sitting in government archives the entire time. In the late 1800s, the American West was being mapped, mined, and settled at a pace nobody had seen before. And wildlife agencies had an idea: turn empty mountain lakes into fishing destinations. The problem was access. These lakes sat above the tree line, past where wagons or roads could reach. So agencies got creative. They loaded milk cans full of fingerling trout onto the backs of mules and led them up narrow mountain trails, sometimes for 2 or 3 days straight, just to reach a single lake. The mortality rate was brutal. Fish died from the jostling, from oxygen loss, from the temperature swings between valley and summit. But enough survived that by the early 1900s, thousands of previously fishless lakes across the Sierra Nevada, the Rockies, and the Cascades had been stocked by hand. Then came aircraft, and stocking a lake stopped being a multi-day expedition. Small planes started flying low over mountain basins and simply dropping fingerlings straight out of the cargo hold, sometimes releasing tens of thousands of fish across dozens of lakes in a single afternoon. California's Department of Fish and Wildlife has aerially stocked lakes almost every year since the 1950s. To someone hiking up decades later and casting a line into a lake that seems completely untouched by civilization, none of that history is visible. It just looks like the fish were always there. And for a long time, that was treated as a success story. More lakes with fish meant more places to hike to and fish in, more tourism dollars, more reason to build trails into the backcountry. Nobody thought to ask what those fish were replacing. It turns out, quite a lot. Alpine lakes above the tree line are some of the harshest environments on Earth. Cold water, short growing seasons, low nutrients. For thousands of years before stocking began, most of these lakes had no fish at all, and that absence let something else take over the top of the food chain: amphibians. Specifically, mountain yellow-legged frogs, a species that had the entire high-elevation lake system almost entirely to itself. These frogs evolved without a single natural predator lurking underwater, which meant they laid their eggs directly in open water, out in the middle of the lake instead of hiding them near shore. For millennia, that worked perfectly fine. Then trout arrived, and trout eat exactly what those frogs had spent thousands of generations never needing to defend against. Researchers studying California's 60-lake basin found that once trout were introduced, mountain yellow-legged frog populations didn't just decline. In lake after lake, they vanished completely, sometimes within a handful of years. A frog that had survived ice ages, that had no evolutionary answer for a predator like this, was wiped out of entire watersheds by a fish that was never supposed to be there in the first place. And the frogs weren't the only casualty. Without amphibians controlling the insect population, and with trout hoovering up everything from zooplankton to dragonfly larvae, the entire structure of these lakes shifted. Some studies found that stocked lakes had up to 20 times fewer invertebrates than untouched ones nearby. Birds that relied on those insects and larvae for food started avoiding stocked lakes altogether. One species being introduced quietly rewired an ecosystem that had existed in balance for 10,000 years. By the 1990s, biologists had put the pieces together, and wildlife agencies were faced with an uncomfortable decision. The fish that generations of anglers had hiked hours to catch, the fish that had become part of the identity of these mountain landscapes, were actively driving a native species toward extinction. So agencies started doing something that sounds almost unthinkable, removing the fish they'd spent a century introducing. In Sequoia and Kings Canyon National Parks, teams began systematically netting trout out of high-elevation lakes, sometimes pulling out thousands of fish from a single basin over multiple seasons, then monitoring what happened next. The results were almost immediate. In lakes where trout were fully removed, mountain yellow-legged frog populations rebounded within a few short years. Some basins saw frog numbers increase more than tenfold. Insect populations recovered. Birds that had abandoned the area came back. An ecosystem that had been quietly unraveling for 100 years started stitching itself back together the moment the one variable that didn't belong was taken out. But here's where it gets complicated, because removing the fish wasn't a universal win. Generations of hikers and anglers had built entire traditions around fishing these remote lakes. Local economies in some mountain towns depend on backcountry fishing permits, and in lakes where trout have been established for over 100 years, some ecologists argue the natural baseline everyone's trying to restore doesn't fully exist anymore anyway. The ecosystem has already adapted around the fish being there. So today, land managers are left drawing a map with two categories. Some lakes are being restored to frog habitat, trout pulled out entirely. Others are being deliberately kept stocked, managed as recreational fisheries, frogs written off as collateral damage in exchange for tourism and tradition. The same mountain range can have one lake teeming with an endangered amphibian a mile from another lake still being aerially restocked every summer. Which brings us back to the original question: how do fish end up in mountain lakes? Not by wind, not by birds. By us, deliberately, over more than a century, using mules and milk cans and airplanes, moving a species into places it had never been able to reach on its own. And now we're the ones deciding, lake by lake, whether to undo it. Because the fish in that lake at 12,000 feet weren't a mystery of nature working itself out. They were a choice someone made decades ago, one that's still quietly reshaping who gets to live up there and who doesn't.